Right, thank you very much, Tracy, and kia ora, and thank you everybody for coming out. It's a real pleasure to be able to speak with you this evening. I'm going to be mainly talking about young onset dementia, which is one of my sort of specialty interests and research interests as well. But I thought what we should maybe do to begin with is talk a bit more generally about dementia, and actually just take a step back and ask, why do we have brains? What are our brains for? Because it's maybe not something we think about all the time. And actually, it's kind of easy to think about, why you have a heart to pump, why you have kidneys to filter things and that. But, why do we actually have brains? I ask my medical students this when I'm lecturing them on cognitive problems, and there's sort of a variety of answers that can come up. But in the interest of time, I'll suggest to you guys why maybe we have brains. And ultimately, I think the reason that we have brains is to build up a model of the world that's around us, sort of processing all this sort of sensory information, through vision, touch, sound, everything, to build up the model of what's going on out there in this environment to guide ourselves purposely around that environment in meaningful ways. Now, when we think about that, we can then think about cognitive functions, which really are just different parts of that overall process of building up a model to move us around the world. And there's words that you've probably all heard of, things like attention or memory, our language, and all of these things, although they're interrelated, and they tend to rely on whole groups of brain regions working together, that you can kind of separate them out a bit, so they overlap, but they're separable as well. And this is important because when we start to look at neurological disorders that affect the brain, they tend to affect particular types or particular networks within the brain, say the memory network or attention or things like that, which leads to almost a fingerprint that can be associated with different disorders. When we talk about dementia is really just a description. It's describing a state that a person is in whereby they've had some loss of some aspects of these cognitive functions like memory or the ability to organise your thoughts properly or language or things like that. And that dysfunction has been to a level that actually it's impairing your sort of activities of daily living, your ability to be independent and do what you want to do. So the word dementia is just a description of a situation. It doesn't actually tell us what's causing that dementia, whether it's something like Alzheimer's disease or mini strokes, or there's a list like that of things that could potentially be causing that. The other thing that I think is always really important to bear in mind is that a person who has dementia, although some of those cognitive functions will be affected, probably not all of them will be. And actually some of them may be working very well. So often it's not everything that's being affected. When we talk about young onset dementia, really we're just describing a situation where this happens to people before the age of 65. Now that's a little bit arbitrary, although it does have kind of real world implications as well. So somebody who gets Alzheimer's disease when they're 55, actually the disease is probably pretty similar to someone who gets it when they're 75. But it can sometimes present in different ways, often affecting some of these different networks, so leading to sort of different clinical problems that we see in the clinic. But actually there's a whole lot of real world implications that come with having problems with your thinking when you're still maybe working a job, when you've got young children that are dependent on you, and these sorts of things. And it's also, our whole health system is really set up for people having problems with their thinking when they're older. And so there's all these extra challenges that come along for people who have a younger onset dementia. And it's not that uncommon. We've got well over 100 people in Canterbury at the moment in this situation, and probably actually more that we don't know about. So it really is something that is a big issue, but it's probably been hasn't had as much press as it maybe should have over time. So that's young onset dementia. And one of the things that we've done in the last few years is set up a clinic here in Christchurch. And actually I think it's the first in New Zealand, certainly to be neurologist-led, that specialises in the management of young onset dementia. And this is Rose, who's a keen junior doctor who spent some time with us last year in the neurology department. And she actually did an audit to look at the diagnoses, so what was going on with the first 100 people that we saw in this young onset dementia or cognitive disorders clinic. And what you can see on the graph, the big sort of blue pie there is people with Alzheimer's disease. So over a quarter of people coming through did have a diagnosis of Alzheimer's disease. So that's still the most common neurodegenerative condition, whether you're young or whether you're old. There are a number of other neurodegenerative conditions that we see. Frontotemporal dementia, which often affects the front of the brain and can change people's behaviour and mood or language often as well. Dementia with Lewy bodies, which can overlap a little bit with Parkinson's in many ways. The other thing that I think is important to point out from the sorts of people we're seeing, so these are all people who have problems with their thinking, and that's why they came to the clinic. Actually, it wasn't a neurodegenerative cause for a number of them, and it was things like depression or anxiety, which can actually manifest very much with problems with sort of thinking and paying attention and memory. Now, there's many challenges that I guess come in the clinic, but I just wanted to focus on one thing, and that's getting an accurate diagnosis for people. Because we know that a number of people, it can take years to actually find out what the underlying cause for their problems that they've noticed are. And that can be a really stressful time, it can be really burdenful for them and their families. And so being able to make an accurate but also timely diagnosis is a really important thing. But it's not always easy. And one of the reasons it's not always easy is because these diseases that we see, these neurodegenerative conditions, can present in lots of different ways. And Alzheimer's is a great example. We think of Alzheimer's as often affecting memory systems, and that still remains a very common way. But actually, and particularly in younger people, it can start in other networks in the brain and affect, say, the ability to process visual information coming in. So that you can almost end up being unable to see properly, even though you can kind of, the basic pathways of vision are there. Or it can affect your language or your ability to organise your thoughts or plan and kind of, multitask and things like that. So that can be a challenge. Also, one symptom, like memory loss, can have a multitude of potential causes, from Alzheimer's disease all the way through to depression or anxiety or a whole lot of other things. And so it can be a little bit hard to unpick these things sometimes. But we want to do it quickly for people so that we can, because there's very different management strategies depending on what the actual cause is. And this is where the idea of biomarkers of underlying neurodegeneration become really, really important. And when I say biomarkers, what I mean is just some sort of measurement that tells us whether there is something going wrong in the brain over and above our clinical exam or what a person reports is going on. And some things that we often use are, so an MRI scan, which we've sort of heard mentioned just briefly, so one of Tracy's areas of expertise. And what we're seeing here, the sort of grey and black image with a blue arrow, is just showing some shrinkage of a particular part of the brain that often happens in people with Alzheimer's. But actually, particularly in younger people when they come in, even if they've got Alzheimer's, that might not be there until very late in the disease. So it doesn't help us initially. On the right, this is a different sort of scan, a very sophisticated scan called an FDG PET, which looks at metabolism, how hard the brain is working. And this is a person who has a frontotemporal dementia. And basically the red arrow is showing reduced work rate within the brain in that area. But that's expensive and we can't access that in the public system. Increasingly, there's been a move within the field to not look at so much these markers of more general markers of brain cell loss, but to look specifically at the pathology of the disease. Now, many of our neurodegenerative disorders, like Alzheimer's disease or dementia with Lewy bodies or the frontotemporal dementias, are characterised by the slow accumulation of abnormal protein within the brain. Now, we've actually recently, there are techniques that have been developed that we can detect that protein in people, either via a lumbar puncture, and this is particularly for Alzheimer's disease that I'm talking here. So either via a lumbar puncture, which we can do now within the public system, but it's quite invasive, or this other thing called an amyloid PET scan, where you give an injection of a bit of tracer and it binds to the abnormal amyloid within a person's brain if they've got Alzheimer's disease. And that's really helpful, but it's really expensive. And again, it's not funded in the public system. So one of the things that we're interested in is there a way that we can kind of get more information out of one of these scans to make it better value for money? Because it is a really helpful diagnostic tool for people. And so we've got a project that Will is working on for his PhD, and it's been sponsored actually by Pacific Radiology, where we're looking at this amyloid PET scan. Normally you have the injection of the tracer and you wait about an hour and then you have your scan to see if it's been taken up by abnormal amyloid protein. But actually when you first inject that tracer, where it goes over the first few minutes tells you something important, potentially, about how hard the brain is working. And we think that it may actually be very similar to that other scan that I mentioned earlier, the FDG PET scan. So you can almost get 2 bytes or 2 bits of really crucial complementary information from one scan. And this is just showing a single person, and actually, to the eye, they basically look identical. And in fact, this graph on the left, you'll have to trust me, but it's very unusual to see a correlation like this in any research that we do. But basically, Each one of those black dots is a spot from within this person's brain. And what you can see, the straight line just tells us that the early phase of the amyloid scan and the FDG PET, so the brain metabolism scan, are very closely related. And so this is going to be one of Will's big projects for his PhD, and we hope that we can show that actually this amyloid PET scan is a really, really valuable tool and better, value for money, ultimately to make it available, hopefully publicly. So just to wrap up, so we've got this cognitive disorders clinic. Its focus is, diagnosis and management of people with young onset dementia, but there's a whole lot of research things that we're looking to do. That really broadly you could think of as understanding more about individual diseases like Alzheimer's disease or others, but also understanding how those circuits, those cognitive functions are affected. For example, we have a lot of research going on at loss of motivation or apathy. And actually, we think that it's more about how the circuit is disrupted more than the underlying pathology. So whether it's Alzheimer's or dementia with Lewy bodies or frontotemporal dementia or strokes, it's more that disruption of the circuit. And so understanding how that works is a really important sort of research goal to ultimately be able to treat some of these problems that people come into the clinic with. And we're doing this both locally and also through international collaborations that we're making. So I'll stop there, but I'm very happy to take questions, probably at the end, I suspect, in the interest of time. But you come and find me. Happy to talk. So thank you very much for your attention.